Alrighty, so we will do a few example problems on Ohm's Law, seeing how to analyze a fairly basic circuit using Ohm's Law and the rules of Ohm's Laws to calculate things like the current running through the circuit, the voltage dropped by a resistor, how much current runs through this branch or that, and things like this. So, of course, before we start, Ohm's Law, V equals IR, is the main equation we're going to be using. And, of course, this can be used both for the total values for the circuit. So if you know how much voltage is running through the circuit and you know the total resistance, then you can get the total current that flows. But it can also be used for individual parts of the circuit. So, for instance, if you want to know how much voltage is dropped by a particular resistor, you could say V equals IR. V is equal to the current that hits that resistor times the resistance of that resistor. And that'll tell you the voltage dropped by that resistor. So this is a nice equation to know. Also, we had a few rules that basically showed how does current and voltage get affected based on if resistors are in series or parallel. And now we're going to use those things to analyze some circuits. So let's take the first example. Let's say we have a circuit that looks something like this. All right. So there's our circuit, and what I'd like to do is fill out this particular table of values given the resistors of 2, 3, and 4. I want to calculate the current and the voltage dropped by each. So the question is asking you to fill out this table here. Now, whenever I get a question like this, the first thing I do is I calculate the total values. So I want to calculate the total resistance first, and then with that, I calculate the total current. So let's look at this circuit. Well, first thing I see is that the 2 and the 4 seem to be in series. So this little branch of the parallel set gives us total resistance of those two is 2 plus 4, because they're in series, which is 6. So now these two give me a total resistance of 6. And then I see this 6 must be in parallel with the 3. So now I could take this parallel set, where the 2 and the 4 are now combined as a single resistor whose resistance is 6. And that resistor is parallel with 3. So 1 over R parallel is 1 over 3 plus the new 1 over 6 I just found. That's 3 over 6, which is 1/2. But notice that's 1 over R parallel. So R parallel itself is 2. And now I have the total resistance. I've collected all the resistors together, combining them one step at a time, and I end up with a single resistor whose resistor is 2. Next, I calculate the total current. So I use V equals IR, which says I is V over R. The total voltage is 10, and total resistance I just calculated to be 2. And so I get current of 5 running through this circuit. So I have current of 5 coming out of that voltage source. All right, now I have all the background information I could possibly need to be able to solve this problem. So what do I want to do? Well, let's see what we have. I have a parallel system. That parallel system consists of 2 branches, a 3, and another branch that has 2 resistors of 2 and 4 that are in series. What I know is that, first of all, the current, when it reaches this little junction right here, it's going to split into two pieces. So that 5 is going to split into two pieces. Some goes to the 3 and some goes to the other branch. But I don't know how much goes to each. So the first thing I know is 5 is not the current for any of these resistors, because that 5 gets broken up before it hits one of the resistors. Okay. However, another thing I know is one of the rules I remember from last video said that if you have parallel resistors, then the voltage dropped by each resistor is the same. So if I look at the top branch, the voltage drop there is the same as the voltage of the bottom branch. Okay? So if I could figure out one of those two voltages, then I know the other one. What do we want to do with that information? Well, the other thing I happen to know about a parallel thing is that if you take the whole parallel set and figure out how much voltage is dropped by that parallel set, that's how much voltage is dropped by each branch. Okay? So if I could figure out how much voltage dropped by this branch, it's the same as the voltage dropped by that branch. And it happens to be the same as the voltage dropped by the whole thing combined. Do I know what that is? I do indeed. I know it two different ways. The first and easiest way to know it is to note that the only thing in this circuit is this parallel set of resistors. Nothing else in the circuit is going to drop any voltage. So that means 10 volts is coming in. It hits this parallel set, and then that's all there is. And one of the rules of circuits is that whatever voltage you start with has to be dropped by the time you get to the end of the circuit. So all the voltage is dropped in one circuit, in one cycle around the circuit. So if I have 10 volts to drop, and there's only one thing, the parallel set, that can drop it, that must mean the parallel set must drop all 10 volts. So if the parallel set drops 10, then the top branch must drop 10 and the bottom branch must drop 10. Now, just as an aside, the other way I can figure that out is to say, well, if I pretend like the circuit was a single resistor with the total resistance I calculated over here of 2, then I could see it quite clearly. The only thing that could drop this voltage of 10 is this resistor right here. So that resistor must drop all 10 volts. And now you just pretend, oh, this one resistor is this parallel set. Okay, that's the other way you can see it. So I now know the top branch drops 10, the bottom branch drops 10. Does that give me any answers? It does. The top branch drops 10 tells me the voltage dropped by the 3 ohm resistor is 10. Now, I cannot say that since the bottom branch drops 10, the 2 and the 4 are also 10. Because, remember, the rule for series resistors, and the 2 and the 4 are in series, is that the voltage dropped is different for each resistor. Now, I know if I add up the voltage dropped by 2 and the voltage dropped by 4, it better be equal to 10, but each one individually is something else. So I'm going to have to do a little more work. One thing I can do, however, is finish up this row of the table for resistor 3. I've got 2 out of the 3 values, so I can get the last. I for 3 is V3 over R3. So that's 10 over 3, which I'll just keep as 10 over 3. It's a nice, clean number, 3.333. All right, so I got one row completely done. That's very nice. What else can I do? Well, in order to figure out how much voltage is dropped by this 2 ohm resistor, I need to know how much current hits that resistor. Because V equals IR. If I know I already know R, I could get V. Do I know I that hits the 2? Well, not directly. I haven't figured it out yet, but I have the ability to figure it out now. And the reason is this. I already know the total resistance is 5. And I know of that 5, 10 over 3 goes to the 3 ohm resistor. So what is ever left must be how much goes to the bottom branch. So let me take I for the bottom branch. I'll call it I sub B just to label it. Must be the total resistance of 5 for the circuit minus the amount that went to the 3, the top branch. Now what is that? 5 minus 10 over 3. 10 over 3, or 5, is the same as 15 over 3. So 15 over 3 minus 10 over 3 is 5 over 3. So now I know how much current goes through the bottom branch. What else does that tell me? The rule for series resistors is that the current is the same for all the resistors. So if 5 over 3 is coming in and hits this 2, that same 5 over 3 is what hits the 4. So now I know the 2 has 5 over 3 for its current, and the 4 also has 5 over 3 for its current. And now we're golden. Now we have 2 out of the 3 values for the 2. So V equals IR, I times R, 5 over 3 times 2 is 10 over 3. And V equals IR for the 4 is 5 over 3 times 4, which is 20 over 3. And now we got it. And that's how we're going to handle these circuits. Here we have a fairly complex system. We've got a system that's a parallel set of resistors, but one of the branches is also series. So it makes my analysis a little bit more deep than it generally would be. But how did I go about doing it? First step, calculate total resistance. That's what I did last week. And so I know how to do it. Add up the 2 and the 4, that gives me 6. Then that branch in parallel with the top branch gives me the total resistance, which is 2. Now that I know the total resistance, I use V equals IR to find the total current, which I got to be 5. Now that 5 splits between the 2 branches, so that doesn't tell me the current for each branch yet. But since this parallel set is the only thing that drops voltage, then the parallel set must drop all 10 volts. And then the rule for parallel resistors is that the voltage dropped by the parallel set is how much voltage is dropped by each branch. So, since the parallel set drops 10, then the top branch must drop 10, and the bottom branch must drop 10. So let's look at the top branch. Top branch drops 10, that's its V. I already know is R, so I can get I by doing V over R for that. Done with the 3. The bottom branch. I know the bottom branch drops 10, however, that bottom branch is a series set. And a series set, each resistor is not the same amount of voltage. However, if you add them all up, you get the 10. So how do I figure out how much is on each resistor? I have to figure out how much current hits those resistors. How did I do that? Well, I already know the total current was 5, and it splits. Some of it goes to the top branch, some goes to the bottom. But because I solved the table for 3, I already know how much goes to the top branch, 10 over 3. So all I got to do is take the total minus the amount that went to the top. That gives me how much goes to the bottom. And so I fill that in. Once I have that, then I just do V equals IR for them. And I got my answers. So it's a whole bunch of little bitty steps, but all the steps are easy. It's just a matter of putting them together. Now, I was able to go through this fairly quickly because I have a lot of experience with it. I've practiced a lot. And maybe when you get a circuit, you may not be able to tell exactly what to do from the very beginning. But that's okay. It's a puzzle. You have to think about it, and you have to try stuff. One thing I can do to make sure I'm correct, because, hey, maybe I'm wrong, let me test. Remember I said the top branch has to drop 10 and the bottom branch has to drop 10. And for the bottom branch, those two resistors have to add up to that 10. Well, is that true? Take the voltage for 2 and the voltage for 4 and add them up. 10 over 3 plus 20 over 3 equals 30 over 3, which is indeed 10. So it works out. That's a check to make sure my math is okay. If I had done something wrong arithmetically, then when I do this check, I wouldn't get the same 10 as the top branch has. And I'd know I did something wrong. So I'd go back and look at my work and see where did I make a mistake. But let's try another example. Okay. All right, 10. We've got 6, 12, 3 and 4. Nope, 2 and 4, whatever. All right, so there's my circuit. Here's the table I want to calculate. RIV. I've got a 2, a 4, a 6, and a 12. And I want to get the I and the V for all of those. As before, I want to calculate the total resistance. So let me start. First thing I would do is take this parallel set and do 1 over R parallel is 1 over 6 plus 1 over 12, which is 3 over 12, which is 1/4. But I need R parallel, so R parallel must be 4. So now that yellow circle, that parallel set there, is one resistor whose resistance is 4. And now I continue. Our series is 2, plus that 4 I just calculated, plus the bottom 4, which is 10. I now know the total resistance of my circuit. It's 10. Next thing I do, I calculate the total current. Well, V equals IR. I is V over R, which is a voltage of 10, and a resistance, I just calculated, it's also 10. So I have a total current of 1. I did all my background work. Now I have all the info I need. Let's get started thinking about this question. Notice I haven't paid attention at all to the table. I'm not thinking about how to solve that yet. I want to get this info first, get it out the way, have it on my paper, and then I start using my, I start thinking about it like it's a puzzle. How do I figure all these little things out? Well, let's see. One thing I just calculated is the total current. How is this useful? Well, look at what the current's doing. The current comes out of the 10. What does it do? It hits the 2. It has no choice but to hit the 2. So all of that current gets into that 2. Thus, I already know the current for 2 is the total current, which is 1. So he's done for I. Then what happens? He leaves the 2, keeps on going. Then it hits this parallel set where it splits into 2 pieces. So I know the 6 and the 12 will not have a current of 1. It's going to be something less than that. How much? I don't know yet. We'll leave it aside for now, but we'll keep going. After it leaves the 6 and the 12, those pieces come back together and keep on going to hit the 4. So that one split goes through the 2 branches, comes back together at the bottom to be 1 again, and that 1 hits the 4. It has no choice. It has to go through the 4. So I know the current, which is the 4, is this total current, which is 1. Thus, current on 4 is also 1. And then it continues along and gets back to the beginning. So this is pretty good. I just got a significant amount of information because note, for these two, the 2 and the 4 ohm resistor on the table, I've got 2 out of the 3 pieces. So I could get the third, V equals IR. For the 2, I is 1, R is 2, 1 times 2 is 2. Done. For the 4, same thing, I times R, 1 times 4, 4. Done for him. All right, what about this parallel set? It always seems like this parallel set is always a little harder. You know, the current splits, so you don't know how much goes to each branch. But let's look at something. Let's use the same trick we tried to use last time, which is it's parallel, so each branch drops the same voltage, and that voltage is the amount of voltage dropped by the whole set. Okay? That is the whole yellow circle thing. That thing acts like one thing and drops a certain amount of voltage. Once you figure that out, each branch drops that amount. Can I figure out how much voltage is dropped by the set? There's 2 ways to do this. One way is to say, look, I already know the resistance of the set is 4. So let me do V equals IR for a 4. I have 1 is hitting the set. Remember, if I think of this parallel set as one thing, it doesn't split. So all the current hits it. The equivalent resistance of that parallel set is the 4. And so I have a total voltage drop of 4. So that would tell me the 6 drops 4 and the 12 drops 4, because if the set drops 4, each branch drops 4, and each branch is a single resistor. So each one drops 4. That's one way to do it. If that's the way you want to do it, fine. That's perfect. To me, there's an easier way. Look at this. I know there's 10 volts to drop in this circuit, and I have to drop all of it. The first resistor, 2, drops 2 volts. The 4 resistor at the bottom drops 4 volts. How much did I have to start with? I had 10. So I started with 10, and then I dropped 2, and then I dropped 4. So 10 minus 6, I'm left with 4 volts. Thus, this parallel set has to drop that 4. It must do it. Well, now that I know the parallel set drops 4, each branch drops 4, and so now I have my 6 and my 12. And now look, yet again, here in the table, 2 out of the 3 pieces, we could get the third easily. I is V over R, so for the 6, I've got 4 over 6, which is 2/3. And then for the 12, V over R, 4 over 12, 1/3. Done. Table's finished. Let's check. What can I check? Let's check the current for the 6 and the 12. I know the total current must be 1, and that 1 split up to get to these 2 branches. So if I add the current in each branch together, it better add up to 1. So let's see. 2/3 from the 6 plus 1/3 from the 12 is 3/3, which is the 1 amp we started with. So that checks out. If this didn't come out to be 1, then I know I screwed something up somewhere and I got to go back and check out my math. However, it checks out, so I'm confident I would box my table and be confident that it's right. So you can see all of these, no matter how I draw the circuit, series, parallel, combinations of both, series inside of a parallel set, however I do it, I'm always doing the same process. The thoughts might be slightly different, but the process is the same. Calculate total resistance, use that to get total current. Once those 2 things are done, look at your particular circuit and say, okay, can I use any of that information to get something at the beginning? Generally speaking, you can. Because let's say you have some series set of resistors. Well, then you know those resistors have the total resistance, the total current hitting them. So you could fill in all the currents. If you don't have a series, then you must have a parallel. And that's good because if you have a parallel, then you just say, well, if it's a parallel set, whatever the voltage is of the circuit, the total voltage, that must be the voltage dropped by the parallel set. And thus, that's the voltage dropped by each branch. And then you use that to fill in the voltages for the branches. And then from there, you just go little by little, trying to deduce what you can figure out using the information you found. So I hope this is helpful. I hope you kind of see the thought process I go through when I do these. There's such a variety of circuits out there. There's no way to do an exhaustive list of them. But you don't have to, because you know all the information already to solve any one I can give you of this type. Obviously, there's extremely complicated circuits out there where we can't use this stuff to figure them out. And that's what the rest of the semester will be about, is more interesting, more complicated tools to try to analyze circuits that cannot be analyzed using Ohm's law. But for now, this is what we need. We're going to use this as much as we can because it's a very powerful tool to use, and it does a good job for what we want it to do. So please, watch over this again if you have to. Work practice problems that are on Canvas. The more you work, the faster you're going to be when it comes to time for the test, because this is the kind of stuff you're going to be doing on this first test whenever it comes up, is filling in these tables and using Ohm's law and the rules of series and parallel to get your information. So sacrifice your time now to make your life easier down the road. If you have any questions, of course, feel free to email me. I'm always willing to help however I can. If you're stuck on a circuit or you think you're doing something wrong, take a picture of it, email it to me, tell me what's going on. I'll help out if it's necessary. I'll draw up my own work and send a picture back to you, however we need to do it. But definitely, if you are having trouble, please email me so we can get it straightened out before we move on to the more advanced techniques. Until next time.